and the video in LeetCode series. Max number of k-sum pairs. So let's read the problem. You are given an integer array, numbers, and an integer k. In one single operation, you can pick two numbers from the array whose sum should be equal to the k, and also remove them from the array so you won't recalculate those numbers again. Return the maximum number of operations you can perform on the array. If you see this directly, you won't think of direct solution, but it's a two-sum problem uh, where you have to sort these numbers and then have one left pointer and right pointer and just do sum, and if that equal to k, then you increase the operation count. There is one more solution as well to this problem using hash map. We will see both these solutions now. Let's write code. Let's first see the two-sum approach. Sort the array first because the numbers are not sorted by default. So sort sorted of nums, define left pointer, define right pointer, while left, sorry, right pointer should be at the end of the array. So length of sort L minus 1 is less than or if sort underscore L of left plus sort underscore L of right is equal to the k, then you define operations count as well as 0, operations plus 1, right, decrease the right pointer, increase the left pointer, elif sort, it's the same but the condition will change. Sort plus L is greater than k, so that we have to, already these numbers are sorted, so we just reduce the right pointer, else increase the right pointer, return operations count. So it's a two-sum approach, and here we are using sorting, so the time complexity will be O of n log n. Most if you use inbuilt function, it will be O of n log n, and space will be O of 1, as we are not using extra array to store these values. Let's see hash map approach. Let's see hash map approach. We define hash map. It's a dictionary in Python, and we just have to add this numbers into this dictionary. If I in nmap, if I is already existing in nmap, just have to increase the count, else create nmap. So as previously, we should also add operations count as 0 and loop through the numbers array. Here we don't, here we're not sorting. Here we just loop through the numbers, and if I in map, I should be in map, and in map of the current value should be greater than 0, so that we know that the value is not yet used, and I less than k. If I is already greater than k, then any value that is added to that I is also greater than k, so we don't have to consider those values. So just stop filtering those things here. If we should calculate the difference. Diff will be k minus I if diff is same as I, so the difference and the number is same, then we should check that nmap value of this difference is greater than 1. Here what we are checking is the numbers are same, so we should have at least two numbers to sum to get to sum, and which should equal to the k. So here we are checking that condition and increasing the operations count as 1 and decreasing the nmap diff to directly 2. We are decreasing the numbers in the hash map. And if diff not equal to I, here we are checking the condition where difference is not the same as I, and nmap of difference is greater than 0, and nmap of I is greater than 0. So we have some values still exist to some, and diff plus I is equal to k, then we can sum those numbers and also remove them from the hash map. Nmap of diff, nmap of I, and increase the operations count. That's it. We return the operations count. Here time complexity will be O of n, because here we are doing one loop and we are doing another loop, so, and space will be O of n because we are using an extra map to store these values. So yeah, thanks for watching.